Good morning. Welcome back. This is day 2 of Forward CloudSec, and I'm excited to kick it off with a topic I know nothing about, which is IBM Cloud. Before we do that, I would like to thank our sponsors, especially IAM Pulse. If you've ever struggled with an IAM policy and thought, well, how did I get here? You are not alone. IAM Pulse is a new community focused on helping folks wrangle those pesky policies. Find us on Twitter at @CheckIAMPulse with your best IAM story, hero, or horror. As always, we'll be taking questions on Slack and in the room. Please raise your hand or ask in the channel thread. Please welcome Riyaz.
Thank you for that warm introduction. Apologies for the quality, the black and white retro look of my webcam. I'm trying to mimic the retro look of how IBM Cloud documentation is as well, right? So I wanted to make sure that my camera, my visual images also look the same. Hi folks, good morning and good evening to you all, depending on where you're joining us from. I'm going to be talking about, as everyone in the room, a bunch of you folks at least would relate to this. IBM Cloud, with the kind of documentation it has and the kind of the amount of material out there in terms of an offensive security mindset, right? I entered the topic with absolutely zero knowledge, right? And this talk is about how I approached an unknown cloud platform, the observations I made on the way, and how I realized that there's actually so much more work to be done with attacking or documenting attacks on IBM Cloud itself. My name is Riyaz Walikar. I'm one of the co-founders of Kloudle along with Akash Mahajan. I also operate as the chief hacker at the company, finding ways to break things and automating that know-how into our product, right? I've been doing offensive security work and research for over a decade now across different fields in the field of security, web apps, mobile, cloud, right, containers, and Kubernetes. And one of the things I specialize with is, and I was able to relate to Rich Mughal's talk yesterday, is to conjure up post-exploitation attack scenarios, right? And with IBM, it was no different. I wanted to get started with figuring out what IBM Cloud offers and how an attacker would approach the IBM Cloud and its different services. A question that a bunch of folks have asked me since my talk was announced on the conference website, as well as when I started tweeting about it, was why did you pick IBM Cloud, right? And there's a couple of reasons. One of the main primary reasons being that I was looking at, I don't know how many of you have played the CTF during Cloud Village at DEF CON this year. But while creating the CTF challenges, I wanted to bring in a little bit of exoticness to the CTF challenges themselves. And that's when I started exploring different cloud services, apart from the big three that everyone is aware of and build challenges day in, day out. And that's when I looked at Alibaba and IBM Cloud as resources. The interesting thing with IBM Cloud was that the amount of documentation there is in terms of how you'd set up a bunch of these things, in my personal opinion, was, it's not sufficient. And more often than not, there were commands that were incorrect in a bunch of places as well. I love reading documentation, but the IBM docs was painful, right? So I set about exploring IBM Cloud in the only other way that I know, right? To set up an account, log in into the portal, set up a service, and see what it has to offer us. Right? So hands-on poking and prodding led to some interesting observations within the IBM Cloud, and that's what this talk is about. And this is an ongoing research, right? This is completely an ongoing research thing, and I realize that we will not be able to fit in all of the observations that I've had in the next 17 odd minutes. But which is why there's a GitHub repo whose link I'll share with the slides, where everyone in the community can contribute. When I look at at a cloud environment, I look at it from 3 different vantage points, right? As an attacker, I'm going to look at it from an external attacker point of view. I'm going to look at it from an internal attacker. And because all cloud platforms work with APIs, and that's the key reason people love working with the cloud, because the APIs that you can use to start and perform cloud operations on services. The cloud attack surface also comes in with the API, right? So your external attack surfaces, your IPs, your DNS, host names, a bunch of legacy pen testing stuff around OSINT, available data, internet-wide visible managed services over TCP/IP, right? And any other visible services accessible as part of the cloud. Your internal attack surfaces, once you've gained access to a machine, for example, what does the internal network look like? Do they have VPCs? Are there subnets? Right? Those questions can be answered with the internal attack surface. And the cloud-specific attack surface, where you can use or steal tokens and then use those to interact with backups, your storage services, bunch of these that require some level of access to either your own cloud, and then you abuse the privileges that are available as public, right, to access data belonging to other accounts. So the approach primarily that I had was I set up a IBM Cloud account. I applied free credits that I had, and they give you a bunch of credits to work with the IBM Cloud for a month or so. Set up the CLI by reading the documentation and some guesswork, and envisioned Acme Corporation using IBM Cloud. And then I started interacting with different services like your compute and storage, things that I was familiar with because I work with AWS on a daily basis. Creating a resource within that service, seeing if any insecure defaults are applied, right? Checking what kind of authentication is required, looking for access that I may already have, and moving on from there. And interestingly, for a bunch of these services, compute or storage, the DNS, the public naming convention, becomes really useful because once you know the naming convention for a bunch of these services that are publicly accessible, you can then perform internet-wide searches using Google for that matter. And we'll take a look at some of these examples. I logged in, I looked around various environments, especially compute services, started an instance to see if metadata exists. Spoiler alert, there's no metadata instance in virtual machines IBM Cloud. Start the Cloud Shell, explore the environment, what kind of container environment is it. Generally start a function, get a reverse shell into the function, look at what the environment has to offer. Document these things, commit to the GitHub repo, and then repeat steps 3, 4, and 5. That's the primary approach that I took. Right? Coming from IBM Cloud being an unknown monster. So we've kind of made a blog post around posting the links of the slides, as well as the GitHub repo. I've just made that public, right? So you would be able to access the contents of the presentation that I'm going to do today, as well as any other observations that I'm going to be making as an ongoing research. And contributions are definitely welcome because this is really nascent at this point. Let's quickly take you through. Let me take you through a couple of interesting observations that I made across different services, right? One of the first things that I wanted to look at was what are the public IP ranges that IBM Cloud has to offer? What does IBM Cloud Services look from the outside as an internet attacker, right? And like your AWS, GCP, and Azure, these folks have published IP ranges. I tried to look through the IBM Cloud's documentation to see if there's any public ranges published. Right? I was not able to find any. Could be a language barrier, but or the data studio not present. I did find a single resource inside IBM Cloud, which turned out to be the documentation for a product, the Cloud Juniper VSRX appliance firewall, but not IBM Cloud in general. Right? But that didn't. So when I looked at it, I still wanted to know what would be the public IP ranges for different IBM Cloud services. One of the quick ways of doing this was to create a floating IP address, which is your equivalent of your elastic IP in AWS. Create a floating IP. Look at the public IP neighborhood using your Hurricane Electric or any other BGP service that provides the AS number for that public IP address, and then look at the neighborhood of that IP address to see if there's anything that maps to what other floating IP addresses that you would create. This is a screenshot of one of the IP addresses that I created, 169.63.85.70, whose CIDR was not in the docs, right? And just to make sure, I created a bunch of other IP addresses in different regions, and I realized that the CIDR for that IP address was not in the docs. That the loan documentation that contains an IP range, right? When you search for, kind of making me kind of enforcing the idea that this is not the public IP range for IBM Cloud. So when I looked at the AS number for the IP addresses, it belongs to Soft Layer Technologies, which makes sense because IBM acquired this in 2013 to build now what is part of IBM Cloud, right? Along with AS36351, which is your primary pool of IP addresses for IBM Cloud, there are a bunch of IPv4 prefixes that point to other AS numbers. And I've kind of made a note of all of these IP addresses inside that link there at ipranges.txt. Some work has to be done about separating them into different ranges, right, or regions. So you would know what belong to Sydney, what belong to UK and US regions, right? So based on the floating IP addresses in each region and walking backwards, I was able to figure out what different IP ranges exist. And one of the things that, when I take a look at one of the IPs, right, and once you have the whole list, you can look at services like Shodan and Census, the screenshot here, for example. You can look up these CIDRs to see if any of the customers that use IBM Cloud have services exposed. I'm not talking about web services. You could have any other service, your Elasticsearch instances, for example, exposed. But from a port number point of view, or from a firewall point of view, you get a list of all services that are being exposed by customers of the IBM Cloud. The one of the key things that is as part of the ongoing work that I'm doing would be to identify the other services that are there inside IBM Cloud. For example, your database instances and stuff, which create or which get assigned a public IP address, but are not a floating IP. Right? The floating IP is associated with your virtual machines, that equivalent of the EC2 instances in AWS. These IP addresses are then needed to be added back to the IP ranges.txt file. Right? That's the additional work that has to be done for the public OSINT bit. Moving on to IBM Cloud Storage. This was interesting because I'm fairly familiar with AWS S3. We work with S3 objects and S3 buckets day in, day out for our customers as well. Two basic types exist in IBM Cloud Storage: the object storage, much like AWS S3, where you have your service instance and then you create a bucket inside that and then you add objects in it, and your file system storage, your block storage for your volumes, and your file storage as well. The object storage supports creation of buckets inside which you place objects. And like AWS S3 again, you can have independent permissions for each object as well as the entire bucket also, right? What is interesting was the naming convention for the IBM Cloud Storage buckets, where you have bucket name .s3, right? .region, .cloud storage, cloud object storage, .app domain, .cloud. The cloud object storage app domain cloud being constant for all bucket types. Given that this is a subdomain of cloud object storage, discovery of buckets on the internet becomes simpler, right? This is a screenshot of a demo IBM bucket that I created with a bunch of files added in, and each of those files can have independent permissions, right? As well as the entire bucket itself. When I look at a public bucket, if you notice, if you would not have seen the URL, this is what AWS S3 bucket list bucket result also looks like, right? It's the same XML format for IBM Cloud Storage as well. And interestingly, if you look at the headers that when you make a curl request to the bucket endpoint, if you look at the response that comes in, the HTTP response that comes in, you'll see a server in the screenshot. You'll see a server : CleverSafe. Right? This obviously makes sense because CleverSafe was the company that built cloud storage objects, and IBM acquired this. Right? And that's kind of the pattern through all other IBM services as well, cloud services as well, where you have a particular service and then you start and then you look at the service domain name, or you look at the headers, right? And the original company that built that service, there are telltale signs of who built it. And it does look that a bunch of these companies were acquired and then just rebranded as IBM Cloud. And that's how the cloud services exist now within the whole umbrella of IBM Cloud. A bucket that's visible and present, 200 okay. A bucket that's absent, 404, that is enough for us to go figure out what buckets exist and not. And you can build a dictionary and then run any subdomain enumeration tool like your AMAS. I have a result on the next slide here. But before I get there, while setting up CLI access to interact with IBM Cloud Object Storage, there were a ton of commands that I had to run to just ensure that the CLI is prepped up. Right? I had to install a separate plugin to interact with the Cloud Object Storage. I had to log in. I had to enable a config auth telling the plugin that I want to use IAM, right? And enumerate the service instance. Then from the service instance, figure out the CRN and then go list buckets. Right? I had to create a separate config for this. That was me after I figured out all the list of commands, because all of these commands are not in a single place in the documentation, right? When I look at the cloud storage, because we know the DNS naming convention and we know distinct HTTP response status codes, when a bucket exists, when a bucket does not exist, we can actually use Google domain search, subdomain search using the site colon operator, for example, to find buckets on the internet that belong to the IBM Cloud. Right? Any subdomain brute force tool also, I've got good results with AMAS and Sublister as well, right? Or something like security trails if you want to use an online service. These are a couple of examples of buckets that are public with IBM Cloud. And weirdly, when I use a Google search, the kind of bucket, the data that Google search gives back, and you'll see this as a trend when you go to the next page as well inside Google search results. There's a lot of phishing pages and other things that are set up. So I don't know what the where these come from. Was IBM Cloud picked up as a favorite of phishing, the folks who do phishing on the internet or not? But there were a couple of Microsoft Outlook phishing pages as well as articles on how to hack Facebook accounts and PDFs and stuff on these buckets. Right? Not very critical enterprise data as such. A couple of things to do with cloud storage as well. Additional things, I want to look at the access policies for cloud storage for objects as well, and check for volume and snapshot storage in the permissions. Like how do you have in AWS where you have snapshots can be assigned the public and then public permission, and they end up becoming public to anybody who has an AWS account. Next, I looked at the IBM Cloud Shell, which turned out to be a Bluemix container pod based on Kubernetes, and was using your your IBM account that you'd logged in, permissions from there, right? A lot of API communication between the CLI or different services is worked with a token called the IAM token, right? And this token was present in session ID folder, which changes every time you kill and restart the session for the Cloud Shell, inside a hidden folder called Bluemix, inside a config.json. This token had full account privileges, right, for your IBM Cloud account in which you logged in. And you could use this token to interact with the REST API as well. The output of your cat proc cgroup kind of telling you that it's running as a Kubernetes pod. And also mount kind of tells you that the container is a Kata container. If you look at the shared folders on my home directory, it's a Kata shared folder, part of your Kata container. This is what the config.json looks like for the IBM Cloud Shell. The token can be picked up and you can reissue REST API calls using only the token. This is the example of the REST API call that I made to list these service instances for inside the cloud storage, right? And that's where the bucket names would pop up. This is what you would see in your, if you browse to that endpoint, if the buckets are public. The IBM Cloud Shell appears to have internal network access. So I want to see if there's additional capabilities I can, invoke or potentially gain root and escape the container. I want to try those things as part of additional work that I want to do with the Cloud Shell. It does have network access, and I'm able to reach IP addresses that don't belong to my IBM Cloud account, right? So I want to investigate those as well. Next, I looked at the IBM Cloud CLI, which is what I was working with so far, and I wanted to see what kind of tokens does it create on my file system, right? As part of when I log in and when I'm working around with the IBM Cloud CLI as well. One of the cool things with IBM I noticed was you could click on your profile button and then generate a one-time passcode. It gives you an entire, the command itself that you can use to log in into the Cloud CLI, right? And this kind of generates a token, the IAM token, sets it to my config file in my current directory in a hidden folder again, and uses this token to make all further requests within the CLI. It's the standard way how your other Azure and AWS CLI also work. The whoami equivalent of your IBM Cloud, the STS equivalent, I would say, is your IBM Cloud account show, which gives you information on who's logged in currently with IBM Cloud, the CLI. Again, locally, the CLI configures a Bluemix folder in which the config.json is there. Very similar to what the Cloud Shell, Cloud Shell config was. You can also use an API key to log in and generate the IAM token separately, right? The IAM token can then be used inside your config.json, and you would have then access from your IBM Cloud CLI as a separate way to do this. No to-dos here with the local CLI. I moved on then to looking at IBM Cloud Functions. And back when I was exploring Lambda as well, a couple of years ago, one of the things that I wanted to do was to look at what the container environment is. So I set up a reverse shell with one of the IBM Cloud Functions that I started, and then use the reverse shell to explore the environment. IBM Cloud Functions are based on Apache OpenWhisk, and there were a couple of CVEs published because there is an endpoint, there's a REST API endpoint within the Cloud Function that executes the code that is part of the function, and the init function of that REST API endpoint had a security flaw where you could post custom code if you're using an SSRF or a code execution vulnerability, for example, and patch the function so that every time it would start, it would then parse the new code that the attacker had provided. Okay, a couple of to-dos as well here. When I'm looking at the capabilities of the Cloud Function, right? I want to see what additional things you can do, or not much based on the capabilities that the container has. But the REST API interface does look that it could have any additional potential issues. Right? The container itself does not have any network tools present, but you can obviously, because you root inside the container, you can install net tools and you have your netstat and other tools available for you to work with the network layer. Okay.
Hey, Riyaz, I want to make sure we save a little bit of time for questions.
Yeah, sure. I'm just going to jump through one thing that I have here. This is the virtual server classic. The root password for any machine that I would start was in plain text, right? That was weird. Cloud databases, right? This is the last bit that I want to cover. When I created a cloud database with the IBM Cloud interface that was available, they have 21 different types of cloud services. You could create a cloud on JSON, which is essentially a NoSQL database. You could create a Postgres. You could create a Mongo. You could create Redis, MySQL. I picked up the first one to just generally see how it would look like, which was Cloud on JSON. Turns out Cloud was a company that IBM acquired, right? This provides an HTTPS endpoint post the creation, and there's an authentication by default here. The URL is of a particularly weird format, which weird for me because I can't use this to find other subdomains on the internet if I would want to do a star.cloudant.com, right? But that would give you the company subdomains, but it wouldn't give me like database subdomains. However, there was a unique header that allowed me to search for exposed databases and their dashboards on the internet, right? That header specifically was called xcloudant action cloudant NoSQLDB.account metainfo.read. And looking at Shodan, there are a couple of, actually 600 odd Cloudant instances running on SoftLayer, Cloudant, and IBM. Right? There are a bunch of them on Amazon as well, possibly through the marketplace, but majority of them through the IBM's cloud interface. Right? So this is going to be interesting because this divulge a lot of enterprise data on the internet. Right, so bug bounty folks, if you're watching this talk, maybe there's an organization there that has published their data on the internet. Right, so a couple of other things to do here: identify any credential requirements, which apart from all the other 20 odd databases that I haven't looked at, which of them allow unauthenticated access by default. Right, that would be also an interesting test case to look at. All right, there's quite a lot of future work that is there. IBM Cloud is being comparable to any other cloud provider out there. There are a lot of services. There are a lot of resources that you would create. Misconfigurations can exist just like any other cloud provider, right? And because of there's not enough documentation. That's not coherent in a lot of places. Mistakes are going to happen and misconfigurations are going to exist. And so the future work that I want to do is essentially around those things. And please, if you have any ideas, and this is again the GitHub repo is public, make sure that you can send your PRs and ideas to me so that we can, as a community, expand the research around the IBM Cloud.
Thanks, Riyaz. One quick question from the channel from Justin. Based on what you've seen, how does IBM Cloud compare to other cloud providers in relation to insecure by default or easily misconfigured services? I think Cloud Databases may have given us a preview there, but
yeah.
Summarize that you're thinking.
I would say, like any other cloud platform out there, when you say there's an insecure default, we've noticed that there are other conditions that make a secure default also insecure at times, right? And it's no different with IBM Cloud as well. The services that I looked at, just a handful of them. I was not able to go through all of them because sheer size. But definitely, I would say that insecurities in terms of using insecure defaults, yeah, comparable to other cloud providers, I think IBM Cloud is a little worse than the others. Right? Simply because the maturity of folks using AWS, Azure, or GCP. Right? There's enough documentation, there's enough training, there's enough dev docs available to how to build secure stuff on these big three cloud platforms, and not so much for IBM and Alibaba and other cloud platforms.
Excellent. Well, thanks for the overview. Next up, we'll have talk on automating security assessments using Cloud Katana. So thanks, Riyaz.
Sure. Thank you so much, folks. Bye-bye.